get right into it. So, welcome once again to today's math class. Um, my name is Olisa Kenechukwu, and this is week 6 of your JUPEB maths tutorial. We've been looking at different topics from the first week up until week 5, and so today we'll be looking at coordinate geometry and trigonometry 1. So the trigonometry topic is actually a 2-part series. So we'll just be looking at an introductory part, sort of, for this week 6, and then for week 7, spoiler, we're going to be looking at the second part, which will go into more details of trigonometry and all the calculations involved with it. So, but then this first part is kind of, like I've said, just an introduction to what it looks like, give you an idea, and so we fit it into week 6 with coordinate geometry. So without further ado, let's get right into it. So we're looking at objectives, learning straight line properties, length, gradient, midpoint, and line equations, line relationships, parallelism and perpendicularity concepts, angle conversion, converting angles from radians to degrees and back, and then trigonometric functions, which is the last of all. So we begin with the first slide. So we're looking at straight lines. Now, before I get into what I have on the slide, I think it's important to explain what the topic is all about, what the concept is all about. So here we are talking about lines, right? So we know that when we have an equation, right? You know, when you're working with algebra, right? So we're working with equations. So when you have an equation, when you have a linear equation, if you decide to plot the graph of that equation, your graph is going to be a straight line, right? This has come up quite a number of times in the past few years because we've looked at quadratic equations, polynomials, and all whatnot. So there we've made the point that for quadratic equations, the graph of a quadratic equation is not a straight line, it's a curve, right? And for polynomials, yes, of course, get higher, the graph changes, right? But for a linear equation, your graph is always going to be a straight line. And why is that? Because the highest power of your variable or variables can have more than one, but the highest power is always 1, right? And so that is what makes it a linear equation. So whenever you plot the graph of that equation, you are going to get a straight line, a linear graph, in a sense, right? So that is basically taking from that algebra and then taking to a geometrical field now, where we now decide to represent this in a pictorial or a graphical form to actually see what our equation looks like. And of course, this has many applications because it's important to also see the behavior of these equations, get the slope, which are parameters in doing your calculations, right? So in geometry, there are important parameters which we are required to be able to determine when it comes to your exams and all these calculations that you'll be asked to do. And so we are just going to outline the important formulas that you need to know and let you know where and when you are supposed to apply them, so that once you see them, you are going to be like, okay, I know this, and then this is what I'm required to do at this particular point, right? So the first thing we're going to be looking at is the length, right? The length of the distance between the 2 points, right? So, of course, in that straight line passes through various points on that graph. So most times, more often than not, you'll be given 2 points on that line, 2 points. So first of all, hope you understand that on that graph, you're going to have the x-axis, which is the horizontal, and the y-axis, which is the vertical, right? So first of all, it's important to understand that concept. So you have 2 axes, the x-axis, the y-axis. And this is important because most times people mix these things, something as basic as this up. And so when you do that, then you mess up everything, right? So it's important to understand the x-axis and the y-axis. So the x-axis is the horizontal, that is the one that is lying on the ground, sort of, if you want to imagine it like that. And then the one that is pointing to the heavens, the vertical, the y-axis. And so when you are required to determine the length or the distance between 2 points on a straight line, the formula to apply is this. So now So as I was saying, when you are given 2 points on a line, now imagine a graph where you have a straight line running through it, right? You trace,
Yes, sir.
you are given 2 points on that graph, on that line, right? You can trace that point to the horizontal, and you can also trace that point to the vertical. Now, if you trace that point to the horizontal axis, to the x-axis, you're going to get to a point, right? Let's call that point x1. If you trace that same point to the vertical axis, you're going to get a point. Let's call that point y1. Now, the second point you are given, if you trace it to the x-axis, you're going to get to a point. Let's call that point x2. And then if you trace it to the vertical axis, you're going to get to another point. Let's call that point y2. So you see that you're given 2 points on the graph, but now you've been able to get what? 4 points on the x and the y axis, respectively, because you have x1 and x2, and you have y1 and y2. Now, it is those points which you have, which you will be given, obviously, that you will use to determine the distance between those 2 points. And of course, you apply them in the formula that is stated here. So the formula for the distance is square root of x2 minus x1 all squared plus y2 minus y1 all squared. And so this simple formula helps you to determine the distance between those 2 points in a straight line. Of course, it's important to remember the order in which they are given. All right, so it's x first, x2 first, and y2 first, not the other way around. Right, x2 minus x1 and y2 minus y1. So this is formula for length. Now, sometimes you might be given those 2 points, and then you will now be asked to find the point. Whitney, the topic is coordinate geometry and trigonometry 1. So I had just started a few minutes earlier, explain what we are looking at, and then I went into explaining what a linear graph is and how we are applying it in sense of geometry to transpose it from a linear equation to the graphical representation geometry. And now we're trying to understand the concepts that we are going to be looking for, right? So when we have a linear graph, when we have a straight line graph, that's what a linear graph is. We are going to be required to find sometimes important parameters that are necessary, right? So the first thing we looked at is the length formula, which is where we just finished before you came on the call. And so I gave an example that if you have a straight line graph, right, and you are given 2 points on that graph, and of course, for a graph, for a Cartesian plane, you have 2 axes. You have the x-axis, which is horizontal, and the y-axis, which is the vertical. So for 1 point on that graph, that straight line graph, you can trace that 1 point down to the horizontal axis, and you're going to meet that x-axis on a point on the x-axis, which we will call x1. You can also trace it to the vertical axis, and you will meet the vertical axis on a point, which we are calling y1, right? Now, if you go to the second point, you can also do the same thing. You can trace that second point to the x-axis and the y-axis, and we can call those 2 points x2 and y2. Now, we have now been shown that to find the length from that x1, from the first point to the second point, you apply the formula using the points on the Cartesian plane. So x2 minus x1 squared plus y2 minus y1 squared. And so, of course, given the 2 points in the straight line graph, you can find the length or the distance between those 2 points using the formula that is stated here, right? And so, having been able to show that concept, I'm moving on to the next one now, which is the midpoint formula. So, if you're given those 2 points on a line, on a straight line graph, you can be required to find the midpoint. So you are given point A and point B, and you want to find the middle of A and B. So let's say you are given, so of course we know how coordinate points are written for a line. So you will see something like in curve bracket, you see something like 2,3 point A, and you see point B 4,5. Now, in case you don't know what that represents, 2,3 simply means that, so the x-axis is written first and then the y-axis is written second. So it simply means that it is 2 units on the x-axis and then 3 units on the y-axis. And then where those points meet, so where 2 on the y-axis meets 3 on the x-axis, that is the first point. And let's say the other point is 5, 10. So we have 5 on the x-axis meets 10 on the y-axis, that's the second point. And those are the 2 points now we are looking at. So 2 and 3 is your x1 and y1, and 5 and 10 is your x2 and y2. So that's simply how the coordinates are represented in that form via that convention. So now that you have, so for the midpoint formula, when you are given those points, you are now asked to find on that line, on that straight line now, where is the midpoint. And so the simple formula for calculating that is x1 plus x2 over 2, comma, y1 plus y2 over 2. Now your answer in this one is going to be, so note your answer here is going to be a single number, right? Because you're calculating a distance, a length, you're going to get a value. But here, in calculating the midpoint, you're going to get a set of coordinates, right? Because you are finding the midpoint, and those midpoints, that midpoint has a point on that line, which also has a coordinate on the x-axis and the y-axis. So the formula is x1 plus x over 2, and this is going to give you the x coordinate of the midpoint, and then y1 plus y2 over 2, which is going to give the y coordinate of the midpoint. And the next thing we're going to be looking at is the slope or gradient, right? So this, you can see this in most texts as gradient, or you see it represented as slope. I'm sure you must have come across any one of these two terms, right? Especially for those that have done practicals or in many different science subjects, right? When you say plot your graph, find the gradient, and all those kinds of things. So because the gradient or slope of a graph is most times very significant depending on what the graph or the equation represents, right? Because it's determining how the two values are changing with respect to each other. So again, the formula still uses those same points we talked about, y1 and y2, x1 and x2. So the gradient or slope formula is represented by y2 minus y1 over x2 minus x1. So it's important to note that in all these formulas, of course, for the addition formula, it is irrelevant kind of the way you order it, because addition is the same thing both ways. But for the slope and gradient formula, it's important to know that it is the 2 of each of them, the subscript of 2 of each of them that comes first. So it's the y2 that comes first, and it's the x2 that comes first, because you're subtracting now. So if you change this order, you know your answer is going to change, right? So it's the y2 that comes first and your x2 that comes first when you are subtracting for the slope formula. And likewise, in the length formula, x2 minus x1 and y2 minus y1 has a squared as well, which is kind of going to cancel out. But it's important to always remember that order, especially when you're going to be solving equations where your sign is going to matter, right? So that is those are the key concepts that you need to be able to know and understand for straight line equations. So now we're going to go into the next thing, which is the equation of a line. So I hope for those of you on the call, you've been following so far. If you have any questions, any observations, anything you'd like to point out now, you can raise them out before I move on to the next slide. Okay, fantastic. So we'll move all right ahead. So the next thing we're going to be looking at now is the equation of a line. So this usually takes two forms. You can have the slope intercept form or the point slope form. So now here we are looking at a case where we want to derive the equation from these parameters that we just looked at, right? So let's say, so okay, before I go into that, I'd like to define the term. So we've already looked at what the gradient or a slope is, and we know the formula for calculating it. But a new term which we have provided here is the intercept, right? So the intercept basically is where that linear graph, that your line, intercepts the y-axis, right? So there is a point where that graph that you've plotted is going to cut through. So of course, if you look at this graph I have here on the side, and you have the x-axis right here, which is horizontal, and you have the y-axis over here, which is vertical, right? There's a point where, so you have a graph running this way. There's a point where it's going to come and intercept this axis here. And so that point now is called the intercept, right? Because that's where it cuts through the y-axis. So normally, if you have the slope and intercept, it is possible to find the equation of that graph, the equation of that line. And the general form of representing it is y is equal to mx plus c, where m stands for the slope and then c is now the y-intercept. So very simply, if you have the slope and the intercept, you can easily just come and plug it in here, where y will not be whatever the slope is. So let's say it's 3, and then whatever the intercept, let's say it's 10. So y equal to 3x plus 10. And that would match up with the exact equation for that graph that has been plotted already, right? Now, the second possible way of finding this is when you are given the slope and you are given 1 point on that line, right? You are given the slope and you are given 1 point on that line, just 1 point anywhere on that line that you have that has plotted on the graph. And so it's possible to be able to derive the equation as well using the point slope form. Now that is denoted by this formula. So that 1 point on the line has a set of coordinates, right? So you can trace it down to x-axis to get your x1 and trace it down to the y-axis to get your y1. And so the formula is now y minus y1 is equal to m, which is your slope, into x minus x1. And so when you now resolve that, you also get an equation of that line that you have been given these parameters for. So either one of these two methods will work depending on the information you are given. But one thing that is common to both of them is that you have slope, right? So it's very important because the slope is what is unique, right? It determines how steep that line is, whether it's going to be like this or like this or like. So it's a very significant parameter of your straight line graphs. So the slope is needed and intercept or 1 point on that straight line graph, and then you'll be able to deduce the equation of that line. So an example is given here, right? So the straight line, so it says that the straight line passes through this point 2, 3, right, with slope 2. And now we are asked to obviously find the equation of the line. So as you can see here, we are given one of the coordinates and we are given the slope. So we don't have the intercept, so we are going to apply the point slope form to be able to find the equation of the line. So very simply, we see that 2, 3, we know that the x is always written before the y. So we know that our x1 is 2 and our y1 is 3. And so we can just simply plug in all the values that we have into the formula. And so we have y minus y1, which is 3, is equal to 2, which is our slope, into x minus x1, which is 2. And so if you rearrange this, if you solve this, which is simple algebra, you'll be able to arrive at the final answer, which is that y is equal to x minus 1. And that is the equation of the line where the slope is 2 and one of the points on it is 2. Yeah, so that is as simple as it gets. So, of course, there are many other examples. Sorry, did you say something?
Yes, the example, can you explain it again?
Okay, what exactly do you not understand?
The 2 and 3 say it's what?
So these are the
2 comma
2, 3 years. So this is a point on the line that we are given, right? So 2, 3 is a point on the line that you are given, right? So then that represents our x and y coordinates. So like I said, x is normally written first and then y is written. So x comma y. So, and in the formula, there's a place where you put in x1 and y1, which is what this 2 here is, and this 3 right here is. Then the slope, which is m, is also 2. And so you put it into the formula, and then you should be able to resolve this as it is here. Just collect your like terms, rearrange the equation, and then arrive at your final answer, which is this. Is there anything that is still unclear? Having looked at that, next thing that we're going to be looking at now are some characteristics of straight line graphs, right? Now, we're going to be looking at the parallel and perpendicular lines. Now, where you have, I believe you understand what parallel lines look like, right? So on the right here, we have an example of a line. So just imagine this is the line that's running through this graph, right? This is a straight line. Now, if I have another line, let's say the line is running here, right? Like this, just a little above it, and it's parallel to this one. So when two lines are parallel, it means that they can never meet, right? So they are parallel to each other. Like you should understand what that means. That's like basic geometry from secondary school. Now there's a relationship between those lines, right? And the relationship is that parallel lines have equal gradients. So it means that the gradients of a line that is parallel to each other, their gradient is going to be the same. Now they are not going to pass through the same points on the graph. They're not going to have the same intercept. So this other one can come and run like this and maybe pass through somewhere between here and here and then continue its own path. So two different paths, right? But then they are parallel, and simply by the virtue of being parallel, the property that relates both of them is that they are. And of course, you can have as many parallel lines as possible, and each of them are going to have their own different equations. But the similar property that connects all parallel lines, all parallel straight lines, is that their slopes are always the same. Their gradients are always the same. So M1 is equal to M2, basically. So using this parameter, using this condition, having it in mind is important, because there are cases where you may need to apply that knowledge. Maybe they give you two different straight line equations and they tell you the graph of this one is parallel to this one. So if they don't give you the information to find the slope of the other one, if you find the slope of the first one, you can simply, by virtue of them telling you that they are parallel, you can just now assume that, okay, since they are parallel, that the slope of this one is equal to the slope of this one. And just like that, you now have the information you need for the second one to be able to solve whatever it is you need to solve. But they may not openly now go and tell you, oh, they are parallel, and so they are still going to be equal, because they expect that you're supposed to know that, right? So they will hint it to you, they will tell you, oh, they are parallel lines, but they will not tell you what you're supposed to know, obviously. So it's important to have it at the back of your mind. So for two parallel straight lines, their gradients are equal. So you calculate the gradient of one, it is the same thing as the gradient of the other, even if you don't have what you require to calculate gradients or the slope. Now that's for parallel lines. For perpendicular lines, it is a little bit different. Now there's also a relationship. So what do I mean by perpendicular lines? So it means that two lines where they are at an angle 90 degrees to each other, right? So you can have two straight line equations where at their intersection points they form an angle, right? Now for those two lines to be perpendicular, it means that that angle they form is 90 degrees, right? So for example, the x-axis and the y-axis are perpendicular to each other because the angle they form is 90 degrees, right? So you can have this straight line. Now you have maybe another line that runs this way somewhere, but it runs at, and it meets this one at an angle that is 90 degrees to it. So by virtue of that, they are perpendicular. So the relationship is that the product of the gradient, so you have M1 as the gradient of the first one and M2 as the gradient of the second one. The product of their gradients is equal to -1. And that's the general rule that applies for all perpendicular lines. The product of their gradients is always equal to -1. So of course, that is also useful information to have. So for example, they can tell you two straight line equations that are perpendicular to each other. and they give you the slope of one of them, and they require you to find something from the second one. But they not give you the slope of the second one, but you need the slope to find whatever it is you need to calculate. You can simply, from the fact that they tell you that those two lines are perpendicular, you can now connect them. So you say M1 times M2 is equal to -1, and you have M1, right? So the only unknown is M2, and you can simply just find M2 and then solve what you need to solve, right? So if, for example, the gradient of a line is 2, and they tell you that the gradient of another line is there which is perpendicular to it, and if you find the gradient of that one, you can simply put it in this formula, and you get that the gradient of the second one is what? -1/2, which is -1/2. So these are the relationship between straight lines that are parallel to each other and perpendicular to each other. So it's important to constantly remember this, because there will be applications. Applications will arise where you have to solve these, and you will not be given all the numbers, and you just feed you with all the information. But they will just put in all those, little, okay, this equation is prior to this, and you will now be the one to be able to detect and, oh, they said this, so it means that this, right? So it's important, because this is what separates the best from the rest. It's important to have all these things at the back of your mind. So once you come across it, it just clicks like a light bulb in your head, and you're, oh, I know what to do. I've seen this before. And then it's important to also know it, right? So yeah, those are the relationships that exist between the parallel lines and the perpendicular lines. So moving on to the next slide, we're going into radians and degrees. Radians and degrees. All right, so we're moving on to the next slide, and we're going to be looking at radians and degrees. So this has to do with angles, right? This has to do with representing the angle. So we just looked at when we the previous time, we just talked about when the lines are perpendicular to each other, it means that it's at 90 degrees, right? So in representing angles, degree is not the only unit which you can use, right? So it's just like there are different SI units for everything, right? So for length, there's feet, there's inches, there's meters, centimeters, and all whatnot, right? So it's important to be able to know the conversion between the units, right? Especially as most of them will come across them more often than not. So in degrees, in angles too, there are 2 degrees. There are 2 units, just 2 of them, which are for angles, and they are radians and degrees. So it's important to be able to know their conversion, right? So for pi radians is 180 degrees. And so if you want to convert an angle from degree to radians, you just multiply that angle by 180, by pi over 180. If you want to convert from radians to degrees, then you multiply by 180 over pi. So simply, for example, 90 is going to be what? 90 times pi over 180, right? And that's going to be pi over 2 radians now. Now, if you want to convert pi over 3 back to degrees, you now have to multiply by what? 180 over pi, and you get 60 degrees. So this is a table that just gives you the a brief summary of the most common trigonometric degrees that we use and what are their respective conversions in radians. So we have 30 as pi over 6 in radians, 45 as pi over 4, 60 as pi over 3, 90 as pi over 2, 180 as pi, 270 as 3 pi over 2, and 360 as 2 pi. Right, so for the very common angles, we have 30, 45, 60, 90, 180, 270, and 360. And these are their corresponding values, radians. So 0, pi over 6, pi over 4, pi over 3, pi over 2, 180 is pi, 3 pi over 2, and 360 is 2 pi, which is the completion of a full circle. Right, so the next slide is now introducing us to trigonometric function. Wonderful. So actually, origin of a trigonometric function. So when we talk about trigonometric function, because that's big grammar, we know what we're talking about, right? The functions that relate to circle, the angles of a circle. So of course the angles come from a full circle. Right now we know that a full circle is what 360 degrees, right? And so when we now break that full circle into parts, and of course 360 degrees in radians is what 2 pi. When we now break that 360 degrees into parts, we now start to come across different angles, right? It's not complete again. And so this is where trigonometric functions come in. These are the functions that define using unit circle for all real theta. So this sign for the angle is theta, right? And so the functions that we know are sine, cos, and tan. These are the basic ones. Of course, there are other 3 functions, but they all get their origin some way, somehow. They are connected to the basic ones. These are the foundation. Baba, you like to use that word, but then without these ones, no other ones would exist, right? So for a trigonometric circle, right? Remember I said that in this the total angle in the circle is 360 degrees, right? Because from this beginning point, let's say this is our starting point. So from here to here, half, which is a quarter, is what 90 degrees. And you can see it's 90 degrees because this is perpendicular to this other line, right? And so for a straight line, this is what 180 degrees. So from here to here, straight line, 180 degrees. And then from here, covering 3/4 to here is what 270 degrees. And then from here, covering the whole thing back to here is 360 degrees, which makes full revolution. Fantastic. So for any angle that is in this first quadrant, no matter the trigonometric function you apply, it is going to be positive. So there's a rule that follows that. So it's ASTC, right? So there's also ACTS, which is ACT, but then ACT works in the opposite direction. But then I'll just show you how this one works. Then you can decide which one you want to use to be able to remember, right? So if you notice when you are solving, so first of all, the trigonometric functions, you can either get the values from your 4-figure table if you own one, right? Or you can use a calculator to be able to derive the answers, right? So if you notice in your 4-figure table, you only go up from 0 to 89 or just about the 90, depending on the 4-figure table. But then you might be required to calculate angles that are more than that, right? You're required to calculate angles that are between 90 and 180, or between 180 and 270, or between 270 and 360, right? Now, there's a neat trick to be able to do this, but then before I go that, let me quickly explain what this ASTC rule is all about, right? So the ASTC rule shows you where each of the trigonometric functions are positive. Now, in the first quadrant, is between 0 and 90. It is all, right? So what does that mean? All means every single term or every single trigonometric function is positive in this first quadrant, right? So all, sine is positive here, cos is positive here, tan is positive here. Now, in the second quadrant, which is the S, sine, so from here now to here, it means that only the sine function is positive and every other one is negative in that second quadrant. The third quadrant, tan, it means that in this third quadrant, any other trigonometric function is going to be negative. But this particular quadrant, if you are doing tan, any angle in this quadrant, you are going to get a positive answer. And then the fourth quadrant is cos, which is the last one. And it means that any other trigonometric function is going to be negative in that quadrant, except cos, which is going to 70 to 360. Wonderful. So I've been able to show you, of course, this is just an introduction. This is by no means the full breakdown of what trigonometry is involved, but this is just like an introduction to show you what is involved. And then the next week's class is going to be a more detailed breakdown of trigonometric functions and how to use them and all of that. But I was going to say something earlier before I went back to explain the ASTC rule. So in the case where you are now given an angle that is not between 0 and 90, right? It is between 90 and 180, it's between 180 and 270, it's between 270 and 360, right? You can figure out what angle is, right?